All right. So the next thing that we're going to talk about is the idea of using being told that two things are congruent to solve for missing sides, right? So I likely should have told you, I should have put it in the problem, but you're being told, okay, in this case, that triangle CDN is congruent to triangle PSN. Okay, that's not something, in this case, we don't have to prove it. We're being told that that's already true. And we want to look at the diagram, and we want to use the diagram to solve for angle C right there. Okay, so this is sort of an easy version of a problem in that there's not a whole lot we have to do other than identify which of these two angles, angle P or angle S it is, right? And it's made even easier by the fact that S is being identified as being congruent to angle D by this little arc right here, right? I see the arc there. So I know that those two angles are the same. They're congruent to each other, and I know that S is 68 degrees, so D is going to be 68 degrees as well. So that's super easy. But we're not looking for angle D, right? We're looking for angle C. So we want to find the angle that's corresponding to C. And because we know that the two triangles are congruent, if I find the angle that's corresponding to C, then that's automatically going to tell me that angle C is equal to the measure of whatever that angle is, right? Because if I prove that two things are congruent, then each corresponding part is congruent, and thus having the same angle measure as another angle. So I can quickly identify angle P down here as my corresponding angle to angle C. It obviously wasn't going to be either of the angles in the middle. That wouldn't make a whole lot of sense. So angle P, and we know that angle P is 75 degrees, and so we can quickly say that angle C, if I can write, is equal to 75 degrees. So maybe I'd want to write that out. Angle C is equal to 75 degrees. And if we had to justify it, because it corresponds to angle P, and our two triangles are congruent. I forgot an E. My goodness. So angle C is congruent to angle P, and that all justifies why I can say that C is equal to 75 degrees. Okay, that was a super easy version, not that hard. Not a whole lot of information, just had to make sure we appropriated the proper angles. This one gets a little bit more difficult. Scroll up a little bit more. And so I've got two polygons, right? Two quadrilaterals, quadrilateral meaning four-sided. Okay, so first one I've got D, E, F, and G, and S, P, Q, and R. Okay, those are my two quadrilaterals. And I want to use that information to solve for X and Y. So now I'm introducing a little bit of algebra. I know we don't necessarily love algebra, but that's part of the deal. Okay, so all I really have to do is identify what the corresponding parts are. So if I need to solve for X and for Y, I can't solve here first because I need X to solve for Y there. So I need to solve for X first, which means I need to find X using that. Okay, so I'm looking for the side that is corresponding to QR. QR looks like it's the longest side, right? And so if I'm looking at the other quadrilateral right there, I identify that QR is going to be corresponding to GF, and I already know that these two shapes are congruent. So if they're congruent, then their side lengths are equal, and so I can say that 2x minus 4 is equal to 12 feet. right? So that's the geometry part, and then I just have to solve for x. So once I was able to identify the corresponding part, I used the information that I knew that these were congruent, and then it was super straightforward, right? So now in algebra skills, I add 4 to both sides. 2x is equal to 16, and I divide by 2, x is equal to 8. Right, so I found my x. One down. Now I want to find y. Slightly more difficult, right? I need to use x to solve for y. The other reason that that's difficult is I'm given 3 angles, so it's a little bit more difficult to determine which side is the corresponding side. Okay, but we can sort of look at this and say, if I look at Q, this angle right here looks like the smallest of the 3 angles. Okay, the other thing I know is it's attached to the side that I just used. Right, so right off the bat, I can eliminate 102 because it's not attached to the side, and then it looks like this angle right here is more similar to that angle than this angle is. So G would correspond to R, and F would correspond to Q. And so if F corresponds to Q, then 6y plus x should be equal to 68 degrees. And so I can go about, oopsies, I can go about solving. All right, so 6y plus x should be equal to 68. I know x is going to be 8, so I can substitute that in. 6y plus 8 is equal to 68. And then I want to solve. So I've got 6y over here is equal to 68 minus 8, which is 60. Divide by 6, divide by 6. I'm getting ahead of myself. Y is equal to 10. So y was 10, x was 8, and I have done what the problem asked for. I solved for x and for y. Right, and I can check my answers by plugging back in x and y to see if they give me the proper answer. So if I plug x and y back in, they should give me out 68. If I plug in x up here, I should get out 12 feet, right? All right, let's look at one more. So again, this one's maybe a little bit easier. Maybe I should have done this one first. But all we're doing is solving for x. I know that these two shapes are congruent to each other, so I just have to identify the angle that is corresponding to 4x plus 5, or which point corresponds to h. And I think that that would be point F. So I'm just looking at picture. It looks like I might have to rotate this 90 degrees that direction for them to be oriented the same. But we want to use that 105 degrees, right? So I say 4x plus 5 is equal to 105 degrees. That's the geometry. Now I'm using my algebra skills to solve for x. So 4x is equal to 100, and then I divide by 4, and x is equal to 25. And so if I wanted to check that, plug 25 back in for x. 4 times 25 is 100, plus 5 is 105, which is what it should be equal to, so we've checked our answer. All right, so now what we've practiced is we've practiced taking the idea of two things being congruent to solve for missing angle measures, missing side lengths, that sort of thing, using the understanding that if things are congruent, specifically angles and side lengths, then their measurements are also equal.